One more mic check. Any better?
It's clear. We're still open air.
Oh, weird. Okay, thanks.
Okay, let us get going. Again, thank you for your patience. So welcome to IDR and IETF 121 on Dublin. Apologies, that the chairs were unable to be in person. We had a number of things all come up at the same time. Please, wave up front and say thank you to G, who's done a lot of legwork to try to make sure that everything goes smoothly in our absence. We have a very tight agenda today, so we'll be trying to keep things moving smoothly. We'll go through brief chair status, and then we'll actually take a look at the agenda and quickly bash it in case there's any very, very last minute changes. So everybody has been seeing the note well. You are bound by it. Please consult your lawyers if you don't understand this. A quick note that the NOMCOM is entering their interview and deliberation phase, so please supply them feedback. They do run office hours. They're the people running around IETF with little orange, orange on their badges. They would appreciate feedback on the various candidates that are trying to become our various leadership positions within IETF. A brief note on working group charter. The IETF chair and the area directors and more general cases have started pressing working groups to update their charter. IDR's charter is rather stale, as is many other working groups. We have actually seen, at least in one case, IESG review blocking advancement of work because things are out of charter. So expect a rechartering discussion to happen sometime in the near future. Quick activity since last IETF. We have send hold timer getting ready to be published. I think that it is literally waiting for the RFC editor to push go. We adopted generic metric, E2E, EPE over L2 bundles. The flow spec v2 work was also adopted, although the individual drafts are still working through the specifics. At this point, entropy label, which is now called the next top dependent characteristics, is waiting a second implementation and otherwise ready to be submitted. And at the ISG at the moment, the SR policy SAFI and SR sig types extensions have been going through commentary. Please watch the list traffic to see how that's going. Deprecate AS set confed set is waiting on the final shepherding report, and then that should be submitted as well. We have several documents that are impending working group last call. The SRVT-MT, and the policy on RTP documents. Please take a look at those. Those have gotten some commentary already on the list, primarily driven by Sue. BFD strict mode at this point is pending myself coordinating with the authors on the last second updates that we did for the finite state machine changes. And once we have our implementations adjusted versus the change of the document, we'll go ahead and try to advance this. This does block the FSMI ANA draft because it is one of the dependent items in there. HBLS SR policy, K10's working through Shepherd comments, and very similar for SR policy cyclist ID. This is working through Shepherd comments. In this case, early allocation is requested, so the working group is requested to please pay particular attention to the cyclist ID draft, simply because they're asking for something that's theoretically for stable code points. Sue has been very busy giving people some early reviews for documents that may or may not have actually been adopted by IDR. Thank you, Sue, for giving us extra attention. This will hopefully help us get these documents moving a little bit faster. We had two IDR interims. The first one was on September 9th, where we covered HBLS and SR presentations. And on the 23rd, we had a second one, which were covering things that were related to HB desktops, particularly the multi-desktop and link bandwidth drafts. One of the things that was highlighted in here is that we do have a need for an update to the extended community RFC to address exactly how non-transitive behaviors are expected to work. There's a level of ambiguity that's causing interop problems. We also have discussion going on with the link bandwidth across not only IDR, but in the best working group as well, and being able to make sure that we're trying to work on a set of features consistently across link bandwidths. So this is going to be an ongoing thing. The other interims were canceled. One of the things that has popped up that is probably going to be worth some working group attention in the near future is broader discussion on limited domains for BGP. The most recent draft that sort of tickled this has been the metadata draft, but we've had other discussions before, and this overlaps things like attribute escape and basically what is BGP being used for private type purposes. Having the ability to do that would be I think would clean up some of the use cases and probably be overall helpful. The chair will discuss, when this piece of work might be able to be, kicked off and what we want it to look like. Final item from the chair slides: the FlowSpec redirect IP draft. We're sort of at the precipice of doing working group last call. Sue has given Shepard comments that need to be addressed. The motivations to push this, forward at the moment was the TS FlowSpec document, and John has a number of comments on that draft that need to be addressed. But since this is also a dependent item, it's a good time to get it done as well. Any brief questions while we pull up the agenda, and we'll give everybody a chance to very briefly bash it just in case. Okay, so here is our agenda for the morning. I'll be going over segment routing policies for BGBLS. K10 will be driving that. More BGBLS for multi-topologies for segment routing. Zhongfeng, I believe, is the speaker for that. We'll have an update on the VPN prefix ORF from Wei. FlowSpec for SRv6 from Jinbin. Packet content filtering for FlowSpec from Yuzha. We'll then move into SRv6 policy list optimizations for Zufar. We have a presentation originally given towards the CIDR Ops working group, and this is basically our first appearance of this in the IDR for FCBGP. We also have Flex Ogle extensions that Irvin's going to be presenting. Jishnu will be presenting BGP for RPKI as the Yang model. And we'll have a presentation from Shenglin about route origin registry issues. And this is an operations based conversation. So part of the discussion here is to help dispatch this to the appropriate working group. There's no additional bashing that we want to do on the agenda. We'll pick up with the first piece, which will be from Ketan.
Thank you. So I'm Ketan Talaulikar of Cisco, presenting on behalf of co-authors an update on this draft BGPLS SR policy.
Jeff, can you help with slides?
I tell you what, G, why don't I stop projecting? You go ahead and take it from your console there. As long as you have it plugged into the keyboard, he can drive it. If you have not given him a clicker that is plugged into your own keyboard, we can drive it remotely. And I have stopped sharing slides. Okay, at this point you need to share your slides, and you'll need to leave your cursor on the slide so they can actually be toggled.
So, okay, Jeff, can you send me the control for the slides?
You have the ability to do that yourself right now. You're looking for the slide button. There you go.
control twice.
Yep.
Okay.
Okay, so a recap of this draft. This is extend BGPLS extensions for advertisement of SR policies from the router head end, but also from like a PCE. This document was last presented at IETF 117 about couple
Can
of
you
years.
make it louder?
Okay. Okay. I'll move closer. So the draft was presented at IETF 117. That was almost couple of years ago. This was split from the original working group document, which has been there in the working group for a long time. So we'll focus on.
Try
Okay, fine. Okay, I think we skip.
going back one.
Right. Yeah, next. Okay, so this is we're presenting an update because we're getting the document ready for working group last call. So on behalf of authors, I would like to present a summary of what are the changes. The main since the presentation at IETF 117, key thing is there has been no changes in any sub TLV, TLVs or encoding. So in that sense, the draft has been pretty stable. But based on implementations that have happened and feedback from the working group, there have been a set of updates on the draft. So two parts. One is from the working group between version 1 and version 5. We have done a lot of clarifications about the SR policy metric type, the descriptors to be used in the NLRI, descriptor TLVs to be used in NLRIs. For the new TLVs that were introduced in 01, we've got code point allocations for IANA. The security considerations and have been added as well. And there are a lot of other editorial updates. So those were the first set of changes. Then more recently from version 5 to 7, Sue has done an extensive Shepherd review. Thank you, Sue. And that has brought out a whole lot of clarifications. I'm listing down the key parts here. One is that the draft did not specify the meaning of flags, or so we use flags in this draft to indicate status, but the meaning of what the clear means. So when the flag is not set, what does it mean? That was not explicitly stated, so that's been clarified. For certain features or details, we have added references to the appropriate RFC 9256, which is the SR policy architecture sections. There is one TLV where we are carrying the PSEP object within BGPLS. This is to avoid proliferation of all the various options that are there in PSEP in BGPLS. We just added a reminder about the size limitations when doing this, especially because BGP updates limited size. And a whole lot of editorial fixes and improvements from Sue's comments. On the implementation section, they have been updated on the IDR wiki. There are 2 implementations, and they have also undergone interop at the ENTC earlier this year, 2024. I'm aware that there are few other implementations. Would encourage that possible, please update it on the wiki. But from IDR working group requirement, I think we are ready. Here. So the authors had already requested a working group last call, and Sue has done the review. We still have to close the review with Sue, but otherwise there's a request for the working group to review, and let's get progress this towards publication. Any questions or clarifications?
Nobody's in the queue.
You say nobody online?
No. It's okay.
Thank you, Ketan. Okay, it looks like our next presentation will be BGBLS for multi-topology segment routing based at RP.
Jeff, do I need to ask for the control for the next slides?
As secretary, you should be able to just share. Please give it a try. I'll keep a watch.
Yeah.
Yes, it's going to make ask each time. I'll just grant it each time.
Okay.
Hello, everyone. My name is Chongfeng Xie of China Telecom.
Can you make it a bit louder?
Okay, no. This presentation is about applicability of BGPS with MT for SAM routing based network resource partitions. Yeah, this is background. NRP consists of a set of dedicated network resources and associated with the field topology, and was introduced in IFC 9543. The mechanisms of building SR-based NRP are described in related drafts, which working documents, and has been resource awareness segments working documents. The RTP mechanism for SR-based NRP are discussed in ASR working group and has been passed the last call. And this document describes the multi-based BGPS mechanisms for SR-based NRP. It aligns with the approach MT-based SRP in IGP, and distributes the NRP topology and the resource attributes to network controller. The inter-domain topology and the T attributes of NRP are also considered. So this document is the information one, and no new BGP extension is introduced. This scope, BGPS is used to distribute following NRP specific information to network controllers. They are inter-domain NRP topology, inter-domain NRP topology, and the resource-aware segments and the associated T attributes of the NRP. So in this document, MT multi-topology ID is used to as a control plane identifier and NRP. And it assumes that each NRP is associated with a unique logical topology in each domains. So for intra-domain NRP topology advertisements, we use MT TLV in BGPS link and NRI, prefix NRI to advertise the per NRP topology informations. And the topology specific, as I said, advertised for the NRP using BGP SR extensions. And for the inter-domain NRP topology advertisements, we also use MDID TLV with BGP EPE to advertise per NRP inter-domains connectivities and topology specific states. So MDID needs to be unified, planned to ensure the consistency both in each domain and on the inter-domain links. Topology specific T attributes advertisement. Topology specific T attributes are used to specify the resource allocated to each NRP. And for example, the maximum link bandwidth subtier is used to advertise the subsite link bandwidth allocated to the NRP identifier by MTID. So we have made new updates. We have updated the terminology and descriptions about NRP to align with IFC 159543 and existing working group documents. And we also updated the scalability considerations and address all the review comments received from Adrian and Sue. Thanks to them. And we also addressed the review comments received recently in Jeff. So we updated the text about MTID TLV according to IFC 9552. We clarified description about the use case where the consistent MPID education different domains cannot be achieved. So we also expressed our thanks to Jeff and also made editorial change. So we think that the latest version documents address all the review comments. And we also deliver this document, press document at the interim meetings. In regard to the intro domains, LSR document has passed working group last calls in LSR working group. So we also believe that this document is ready for working group last call in IDR working group. That's it. Thank you.
So any comments on this? No, on this slides? No.
Microphone queue is Keeler.
Thank you.
Thank you for the presentation. The next presentation is going to be covering VPN prefix ORFs. Channeling Sue from text. If there's any comments on this, please give them. Otherwise, the document's likely to go to working group last call shortly.
Good afternoon. I'm Wei Wang from China Telecom, and I would like to give a brief introduction. I would like to give a brief introduction about the updates on VPN prefix ORF for BGP4 since the IETF 119 IDR working group meeting. We mainly made the following updates. First, we modified some descriptions according to Kuryu's suggestion, and we modified the format of SPEC, and we also newly defined the source PE AS TLV to carry the AS number of the source PE. We deleted the section 10.4 and add a new section contributors. And we changed the source PE extended community TLV to source PE identifier TLV. Yes, we refine the contents of the whole draft as shown in these two figures. We have changed the descriptions of the detailed procedure for no quota value is set on PE from the form shown in the left picture to the form shown in the right picture to make it more readable. And such modifications has been done in the whole draft, especially in section 4 and 7. And in section 5, the AS number field is in the source P extended community is removed. And this extended community only carries the identifier of the source PE. And we defined a new TLV in section 6.2, the source AS TLV, and it can carry the S number of source PE. Its value can be obtained from the value of source AS in the source AS extended community, which defined in RFC 6514. Oh.
Next one.
Okay, thank you. And we also made some other updates. we removed the section 10.4, and the result of experiments and the implementations will be posted on the protocol implementation reports. And due to the limit of the number of authors, Shunwan was moved to the section 13 contributors. And to avoid the misunderstanding between the source PE extended community TLV and the source PE extended community, we have renamed the source PE extended community TLV to source PE identifier TLV. And we also made some simple comparison here. The source PE identifier TLV is a TLV type of VPN prefix ORF to carry the originator or router ID in source PE extended community for source PE. And the source PE extended community is a newly defined transitive extended community to transmit the identifier of the source between different AS. And we also add two implementations to the protocol implementation reports. H3C has implemented some VPN prefix ORF mechanisms related functions by configuring VRF prefix limit and the quota. They can achieve the use of RD and source PE to control VPN routing, and they can generating, transmitting, and processing type 1 and 2 source PE TLV, and also using the offending VPN routes process method to revoke all routers. And we also has implemented the following functions based on the open source BGP implementations. We achieved the VPN prefix RF mechanism triggered based on VRF limit in intro and inter-domain scenarios. And we also achieved the RD-based VPN routing filtering in intro and inter-domain scenarios. Yes, that's all about the updates on this draft. And any suggestions or comments are welcome. Thank you.
Any comments?
Couple of comments from the chairs. So channeling Sue, from the text, Kayer and Sue would like feedback on the new formats, for the text that's in question. And I think overall we'd appreciate working group review of this document. This is a tricky set of procedures, and we'd like to help everybody get it correct. A question I have you had any considerations for maybe doing a Yang document at some later point once this is stabilized?
Sorry, which slide?
No slide. Have you considered doing a Yang model for this feature?
Yang model. Yeah, Yang model for this feature.
We haven't do any Yang model. Which currently we just achieve some basic functions of VPN prefix ORF mechanism, and maybe when this technology is mature enough, we can do some research on the related Yang models.
Okay, thank you.
Thank you.
Okay, thank you.
Okay, our next presentation is intended to be on flow spec for SRv6.
Okay, this is Zhenbin from Huawei. Today we introduce the two drafts related with the BGP's flow spec on the SRV6. In fact, this draft appears for some time. We refresh this draft and introduce this one on the author team. The first draft is the BGP flow spec for the SRV6. Okay, so this document specify this the when new this the BGP flow specification common type to support the SRV6 filtering for the BGP flow spec version 2. In fact, this is the concrete, this is the definition for the flow specification for the SRV6. Yeah, because this is the for the SRV6, they defined the seed. The format is the locator function and the arguments. And in fact, when this is the filtering, so that's it's not like this the normal this the IPv6 address. So that's may match this some this the fields of this SRV6 the segment. So they need to define this new component is for this matching some parts of the SRV6 segment. Okay, so here this is the definition. So this when this the when this for this the filtering. So we have the search this new this the new encoding. This include this the type, and then this is the locator length, and this is the function length, and this is the arguments length for the SRV6 segment. And following this the length of the different parts of the SRV segment. That's the pair of this the operation and this the value. So this is the operator operation. This is the bytes encoded as this the also this is the bit mask. So here we have this the different this is the flag, and this is for this the operator. Okay, in fact, this the draft is proposed. So this just refreshed. Sorry, that's I'm too busy to cope with this. The comments is in the main list. So that's the the first. So that's we need the coordinate with the BGP flow spec version 2 work. Yeah. So and the second. So they solicit with comments and refine draft. It seems the student is online, so maybe
Yeah, Sue is in the queue.
yeah, student first. Yeah. Okay.
Hi, Sue. We cannot hear you.
Hi, Robin.
Yeah. Okay. Yeah.
Just to give some feedback for the working group, this is part of the presentation I'd intended to do before Robin, but thanks to my illness, I'm just going to have to give you a little context now. The FlowSpec v2 work, we agreed to do a basic that did not contain any additional components. However, the more filters edition will contain this one. The more filters edition had this component in the draft hairs more IP filters. However, I asked the people doing those drafts to split them out if they wished. So Robin is splitting out the draft and going back to its original function. We hope that this will help implementation choices. So you'll see a revision of both of these drafts. So you have the basic more filters with the specific NLRI that has the more filters. This would be one of the components added. Thank you, Robin, for letting me add that little bit. I will explain more of this on Friday, and perhaps by then, Robin and I will have time to chat remotely. Thank you, Robin, for your patience.
Okay, okay. Thank you, Sue. So we would like to coordinate with the BGP flow spec version 2 work. Yeah. Okay. So then this is the next one. This is the flow spec in direction ID redirect for the SRv6. Yeah. In fact, this there's the one this the documents that's the flow flow spec. This is the indirection ID is for the IPv. No, in fact, this is the in fact we already have this draft. This is the indirection ID to the specific path. But you know that's for the SRv6, that when define this the indirection ID is the 32 bits. But we know that's for the SRv6. So there's the SRv6 policy. For example, we have this the binding seed. So that's the to indicate this the SRv6 the policy. So we have this we have this the binding seed is 128 bits. So that's because of SRv6, there's introduced this the new this requirement on this the indirection ID redirection. So in order to satisfy this the requirement, so they define this document defined a new subtype value for the SRv6 in the flow spec redirect to indirection ID extended community. So this is the basic idea. So this is the extended community is 128 bits for the generalized indirection ID. Yeah, besides this the type or subtype and the flag and the ID type. So for this the generalized indirection this ID, there's the possible this context this the types. So I will not identify each one this repeatedly, but at least so there's the reminder in the mind. So that's either for the SRv6. There's the possible the 128 bits for the indirection ID to indicate the path. Yeah. Okay, so because this draft is proposed, this is for a long time, so we would like to solicit comments and refine the draft, and then request for working group adoption. Okay, yeah, that's all.
So again, I'm going to make a few comments because I was supposed to present ahead of Robin. So when we agreed to adopt the split that's in draft IETF IDR flow spec v2 basic, we agreed that we would pick up actions that were flow spec v2, but in the existing extended community, and then look toward an ordered action. The thing that has to happen with all of the actions in the extended community is we have to agree on an ordering, which is what you'll see. So my comments toward this draft and path redirect and several others is that ordering and that failure comments. We will start working group adoption for the actions after we've gone through those revisions in a group. So the actions for path redirect or IP redirect or the other things that are existing working groups, please look at those, and we'll hope to have a confirming call. And then for these new ones, we'll hope to have an adoption call. Please see Friday, as I will try to provide all the scope on that. And again, I apologize I'm not there personally, or that this presentation isn't ahead of Robin. Robin, thank you again for your kind patience with me.
Okay. Okay, thanks, Sue. Okay. Okay. Okay,
Okay,
thank you.
thank you. Packet content.
Hello everyone, I'm Yujia from Zhongguancun Lab, and the topic of my presentation is about the packet content filter for BGP flow spec. For the convenience, we can also call it payload filter, and it's a part of work into the flow spec v2. And we first proposed the packet content filter in IETF 119, and then we joined FlowSpec v2 design team work and conduct software router function development and testbed validation. And we also discussed with some vendors and operators to optimize the filter definition. At this time, I will introduce the latest work of this draft. Here is the problem statement. As we know, the Cairo network cannot defend well in face of some volumetric DDoS attacks, especially for our hundreds of Gbps or TBPS level attacks. And we collect some real-world attacks in the Cairo networks which cannot be dealt with well recently. And the first is a carpet bombing attack. It has more than 300 Gbps traffic affecting over 200 IP addresses. The operation engineer can only defend this kind of attacks by the cleaning device or the firewall right now, but because it affecting too many IP addresses, so they always can be defend it manually. And the second example is a SSDP attack, which is captured last month in the Cairo network. The traffic of these attacks is not significant, but the source and destination port and IP are random. So for the traditional flow spec, they cannot be defended well because we cannot match this kind of traffic. But the lucky thing is both of them attacks have a fixed payload in their packets. So we think it's necessary to propose a new type of flow spec filter to implement the defense against DDoS attacks. And here is the definition of the packet content filter. It is suitable for the definition of the FlowSpec v2, which contains some fields such as order, dependent filter chain, and filter types, and something others. And in the latest work, after discuss with some vendors, we update the definition of the offset type and divide the UDP and TCP payload into two categories. And we also have a question in this field is, do we need more offset type because such as the MPLS or some other protocol? Because for some tunnel or VPN situations, maybe we need it. So we're hoping to have more comments. And the component ordering is also an important work of this draft because as we know, the flow spec v2 is used to, flow spec v2 find if we have multiple rules, the order of the rules will influence the result of the matching. So we try to find some situations which can be influenced, the results of the matching. And here are some situations I will introduce an interesting one, which is the second. As we can see in the slides, we have two rules. The first is using to match the UDP float, and the second is using to match SMP float. They are different, but actually in the using, they will match same traffic because the head of the packet of the UDP and SMP are same. They are the 8 octet. So the ordering rule is important, especially for they have different actions. And we gave a certain ordering rules to determine which rule will be installed earlier. If anyone interested in, please see in the draft or the last conference, I have been introduced in detail. And we also do some development and validation work before we build a test bed in some open source software routing such as OpenBGPD and FR routing. We can find the code in the GitHub, and the validation is contained two parts. The first one is for the network layer attacks, and as we can see in the figure, when the flow spec start, the attack can be discarded in the router, and it can reduce the defense cost of cleaning devices. And the second validation is about the application layer attack. It can be seen in the figure, the HTTP GET request and TCP retransmission packets can be discarded. But there also have some other TCP packets, such as the SYN, ASIC, and finish packet cannot be defended. So it can effectively defend 25 to 55 HTTP float attacks, and combined with cleaning device, we can achieve full traffic defense. Here is a use case to show how to use the payload filter in the Carol network. At the first, the traffic will mirror to the detecting device. If it thinks there may happen some attacks, it can send the flow spec rows to the routers. And the attack one, maybe it's a simple attack, so it can be rate limit or dropped in the router. But the attack two is a complex. Attack two is a complex attack, so it may be to have to redirect to the cleaning device to make a double check, and then the cleaning traffic will come to the destinations. To achieve this use case, we made to use some flow spec V2 function, such as the dependency chain, because for the attack one, it has 3 rules. They are dependent, and for attack two, they only have 1 rules. So maybe I think it's our important work in the next step. And also, we will actively participate in the flow spec V2 work, and we will validate the filter in hardware devices and the Carol networks. We are welcoming for every questions and comments, and everyone can contact me through the emails. Thank you.
Thank you. Any comments? No? Okay. Thank you. So the next one is Safa.
This is Sue. I should make a comment on the last presentation.
Okay.
The last presentation is on another new component for the flow spec V2 work in the more IP filters, and you can see how useful it is. I want to thank the authors, all of them, for their hard work with flow spec V2. And apologize for not getting to the comment sooner, G. Thank you.
Thank you, Sue.
Thank you. My name is Zafar Ali. I'm presenting this on behalf of my co-author Rajesh and Chinli. Next slide, second control.
Yeah, try.
Okay, so let's go over the problem statement. So what happened in SRv6 policy when a service is steered on SRv6 policy, let's say a VPN service, the VPN set has locator information. The policy endpoint, if it happens to be the node SID, the endpoint, the last SID in the SID list, if it happened to be node SID, in that case, you have a case of egress had to deal with back-to-back local SIDs. Traffic is already carrying the policy or policy traffic is already forwarding to egress using the service SID. So in that case, the SID list optimization could be done by removing the endpoint node SID from the policy. And this can also happen not only in the service SID case, in the case when a binding SID is used, because binding SID also carries the traffic toward the endpoint. So that's the case of a transit policy case when the next SID is binding SID. And you have a transit policy case, and same thing can happen with EPE SID. So the idea is to be able to optimize for better compression and not carry the endpoint node SID in those use cases. So now the question is, I give some example like SRv6 service SID where locator is carrying the traffic to the endpoint and binding SID and EPE SID, but there are cases where that is not the case. Say, for instance, if SRv6 traffic is to be transported to carry MPLS traffic, SRv6 policy is carrying MPLS traffic, then you have to have SRv6 endpoint SID carry traffic to the endpoint node. You cannot just remove. So it's not that you can always remove, but it really depends on the steering scenario that you have. So one point is, and there's some discussion going on the mailing list and privately as well, and that is about whether this attribute that you can include an exclusion flag attribute, is it a policy level or candidate path level attribute, or is it the SID list level? So in the draft, this attribute is a policy attribute, and obviously by the virtue of how the protocol extension are defined, is a candidate path attribute. And the reason is this: say, for instance, if you have a policy carrying traffic, MPLS traffic, SRv6 policy carrying MPLS traffic, and if you have all the SID lists needs to behave in the same way, because you need to have that endpoint node SID in your SID list, so you can carry the traffic to the endpoint. So it's not that you can cherry pick. This is a steering behavior at the policy level. This is not a per segment list steering behavior. And this is why in this draft, we have defined it as an end flag at the SRv6 binding SID sub TLV of the which is defined in the SR policy SAFI draft, and an end flag in the SR candidate path state sub TLV in the BGPLS policy draft. Now there is some discussion going on and with Yusong and the author on the other draft, and we have agreed to work together to merge the documents and carry on this discussion. There is a mailing list discussion as well going on this. So at the moment, what we would like to do is like to get the working group feedback as well on this discussion. And the next step really is to work with Yu Xiong and other co-author for another draft which addresses the same area, and combine the document and come back to the working group with a combined merged document. Any comments?
Yeah, we have comments. We have people in the queue. The first is Andrew.
Hi, Andrew Stone, Nokia. So my understanding, obviously there's this draft in IDR for BGP, and there's a sibling one in PSEP. One in PSEP will obviously tackle independently. For the one in BGP, my understanding is the intention of the N flag is to tell the head end node, you may or may not include the node SID. And so the idea is if you know that your traffic flow is service steered, you already have the locator built in the service SID, right? That's my understanding.
That is correct.
And so the value of that, like you mentioned, is that you can save on the having essentially two SIDs for the same terminating node, that redundancy, so that before you get better compression. I think what I was missing from the draft is what is the implication when you're computing that SID list, when you're evaluating it for MSD? So if the purpose is to compress more, because you're trying to compress to satisfy MSD, if you don't know that the head end will or will not be, let's say, service steered, you're kind of still just doing your best effort compression anyways. And so I guess what I'm trying to see is, should there be some text in here that says, when you're computing that SID list, you should still respect MSD. However, if the head end node does have to push the end node on it, that might actually exceed MSD at that point, and therefore be, inability to forward. So I think the use case makes total sense in terms of service steering, but in those cases, like you mentioned, where it's not applicable, the controller pushing it down doesn't know that it's not going to be in that applicable case. So in that situation, it might exceed MSD, so it might actually fail to forward in that situation. I hope this kind of makes sense. It's just kind of on the topic of MSD and what that means in this context. Thanks.
No, thank you, Andrew. There are two aspects. So I like to break it down into two different things. One thing is that not in this draft, because this is outside the scope of the IDR draft, but the PSEP draft. PSEP draft does talk about when a PC compute the path, it must compute it to the endpoint. It does have that statement. Now, the second thing is with respect to the MSD consideration, there is missing text on both drafts. I'll reach out to you and work out those details. Okay, thank you.
Sounds good, thanks.
Thank you.
Okay, the next is Rubin.
I'm Rubin Liu from H3C. I have two questions. One, with the candidate path, it's not possible to represent two different segment lists at the same time. There is a flag at the path level that can control it. The segment list loose and the other is strict path. The other question is the BSID might not always exist. So here we extend based on SID not always available. Clear?
Okay, I think I'm trying to guess question, but I did not follow completely your question. But I think the first question was about the path and the attributes within the path. And that goes back to the discussion of whether this is a path attribute or is a policy attribute. Because it's the steering part, it is a policy attribute. At the path level, in the endpoint node already know that whether the last SID is a UA or a UN. So that part, when you have the information available at the policy level, you can always apply at the SID list level. But all the SID list has to have a consistent behavior. It's not the path attribute. So all SID list has to have a consistent behavior for steering. So that is the point that I covered earlier. I did not get your second part of the thing, but I'm happy to discuss it here or offline. The binding SID, if you have a transit binding SID, that it always has a locator. The transit remote binding SID always has a locator in it. So I did not get the comment. So if the comment is, yeah, so if you have a transit binding SID case, then the locator is part of the binding SID, the remote binding SID.
Thank you.
Thank you.
Okay. Thank you. So the next one is Zhuo Tao.
Hello, folks. This is Zhuo Tao from Tsinghua University. We would like to have an update for the FCBGP protocol specification. This is the outline. So we have been talking about FCBGP for multiple IETF meetings, and since then we received a lot of comments, and today we are going to review all of them and see all the updates according to these comments. So very basic recap of FCBGP is trying to solve the problem of a secure routing protocol in case of partial deployment. So it uses a per pass validation scheme. It is trying to be complementary with BGP-SEC, basically. So this is a table of all the comments and suggestions over the last 2 IETF meetings. And we are very appreciated all these comments and all the suggestions over the past 2 meetings. According to these meetings, we have compiled a list of all these changes, including whether the draft is too light, or how the security is compared with BGP-SEC, and there are a bunch of other stuff I will basically go over through today's meeting. So all the draft update summary can be summarized into 4 categories. The first category is the comparison with BGP-SEC, and the second one is how we can refine the FCBGP protocol, and the third one is how we can have the interoperability with BGP-SEC, how it's compatible with BGP-SEC, and also there are some bunch of other operational and security considerations. So the major change, the beginning change is a comparison with BGP-SEC. So it's not really a comparison per se. It's actually the motivation why we have this FCBGP, because we already have the BGP-SEC. So the key motivation here is like we want to have something that is workable, that makes sense in the case of a partial deployment. So we want to see whether we can have a protocol that can improve the routing security when only part of the network is upgraded. And that's why we have this FCBGP protocol is trying to incentivize the momentum of deploying secure protocols. That's the major reason we have this FCBGP. So as a result of that, we hope to make sure that in case of full deployment, which means everybody deploys this protocol, the FCBGP and the BGP-SEC are equivalent. But in case of a partial deployment, the FCBGP have more security benefits, so we can incentivize all the ASs to upgrade. So besides this very high-level comparison, we also do a lot of protocol change according to all the comments previously. And there are a bunch of highlights I want to go over here. The first one is we refine the FCBGP protocol for processing all the BGP update messages, including when we receive the FCBGP update, how we should verify that, and when we send in this BGP update, how we should propagate this FCBGP update. This is all the tags we have in our draft. And second and third one is to flag usage. Basically, the first one is consider about the AS confederation, and the second one is consider about route server, which we use 2 flags to differentiate these 2 corner cases, basically. Then there is another change about the RPK and BGP-SEC certification key as well. And we also we clarify that FCBGP, similar as BGP-SEC, we rely on RPKI to provide the keys for signing and verification. The second part of high-level change, the third part of high-level change is about interoperability with BGP-SEC. So what if there will be coexistence with BGP and BGP-SEC and FC-BGP here. So basically, we can think of that these two stuff are transparent to each other. So because FC-BGP does not change, does not touch the AS parse attribute. Instead, it defines a new path attribute, which is independent with BGP-SEC. So in most of the case, these two protocols are transparent to each other. But in rare cases where, although it's not recommended as to that an AS should enable BGP-SEC and FC-BGP simultaneously, but what if that happened? The solution is that the general principle is the AS should prioritize BGP-SEC over FC-BGP. In most of the cases, you should basically only enable one of these secure protocols because they were sort of like transparent to each other. And we do have the third summary is that we have cover a bunch of operational and security considerations. The first one is the route selection. So we reaffirm that we do not modify the priority of the BGP route selection in FC-BGP. So although FC-BGP provides a way for the AS to assess all these routes, but we do not recommend any sort of like routing selection policies. It's still part of the AS's local preferences. Oh, didn't work.
No.
Next slide. Okay. And also there's another security consideration regarding as the inserting AS number 0, and we clarify this problem of because ASN0 is a reserved field that reserved number that is directed to a non-routable network. So we use this ASN0 as the case when the when the source AS generates the FC commitment. And we also would like to update some implemented status. So currently we have two versions of implementations. The first is based on software, based on FRR, which we have implement this entire FC-BGP protocol over there, and we plan to open source this very soon. Another one is we have a H3C commercial release, which is in the current testing stage. For the next step, we are certainly looking for a working group adoption, but we are also open to discuss which working group is more appropriate. And we are looking forward to hear from the community to find a appropriate place for this kind of documentation. That's all. Thank you.
Okay, comments?
Maria, developer of BERT. I'd like to ask you whether you have considered performance issues, notably how long would it take to actually check all those signatures? How long would it take to create those signatures? And how are you going to deal with the decoupling of all the routes? Basically, instead of sending bunches of routes with the same attributes in one update, because for now, if I look at the draft correctly, it looks like you are sending one update per each route, and this is not going to scale.
Thank you for your question. So regarding the first two questions, like the overhead of how long does it to generate the signature, how long does it to verify the signature. So we do have some evaluation in the previous talks. The time is relatively light. It's acceptable according to like the network latency stuff. The second question is like yeah, you are right. We do generate each update for each prefix. That's the things we are trying to working on is how we can do the prefix aggregation as well.
My question wasn't about the performance considering the network, but performance considering the CPU. Because if you are loading your route server for 10 minutes, you don't want to update it to like 30 or 40. So I'm asking about the performance in comparison to the best route selection algorithm, or to putting these routes into different, to sending these routes to different peers.
Yeah, I got you. Like the time it takes for the signature generation and verification is in order of microseconds for each single update. compared to what?
Sorry for eating the time. Several microseconds is too much compared to the best route selection. Best route selection can be done under a microsecond.
Okay. Okay, Jeff.
Thank you, Chi. So I have several comments. First, to Maria's point, BGP-SEC is something you should take a look at because the mailing list from that goes through a lot of the design issues. I think John will probably hit a few more of those in his commentary, including the fact that the packing is exactly as bad as you think it is and that the performance is exactly as worse as you think it is. None of these things are free. That's the problem with security. So my two sets of comments. Comment set number one, you have in your prior slide that you're doing implementations. There's no assigned code point for this. What are you doing?
I didn't really get the second part. So what's the question there?
BGP requires that a ASPath code point is assigned to be able to implement the code. You say this is going to be in shipping code, including open source. You have not requested a code point from IANA.
But we don't change the AS parse. Did I miss your question? We don't change the AS parse attribute there over actually.
Correct, but you have the FC attribute, which is a brand new path attribute.
Yeah, that's a new one.
You have not requested a code point from IANA for this.
Yeah, we haven't yet. So, yeah.
Okay, so the question, to say it again, you understand that this needs to be done, but you say that there are implementations. Implementations means that you have done something.
The implementation currently is not sort of like, we have not open sourced yet, right? So we are having this sort of like a x86 platform to test basically the protocol stuff there.
Okay, I will post to the mailing list some guidelines about requesting code points.
Absolutely.
Yes. We wish to make sure that you do not ship code that has an unassigned code point. This causes large problems for the internet.
Yeah,
so my second question is about FCBGP itself on the signatures. So I'm modestly familiar with BGP-SEC. The thing that I'm confused or concerned about for the FCBGP attribute is the tuple that you sign against. The prior AS, the current AS, the next AS, and the prefix. I understand these things. In BGP-SEC, you sign against the chain of them, which is part of why it has no incremental deployment, no considerations. If you don't follow the procedures that BGP-SEC does to do a signature chain, this means you can copy and paste an FCBGP attribute from any route anywhere on the internet and paste it into your own and have no assurances that this has actually touched something. Well, there's potentially some value to putting your own attestation about what your AS thinks that it has received and sent to. It gives no guarantees as to what it has passed through. Is that your intentional value proposition?
That's a very good question, actually. So we do have a security proof that saying like the copy and paste doesn't work. That means you cannot really copy and paste to basically forge a non-existing path.
Is this security proof inside the internet draft?
So in the draft we refer to an archive paper, which is over there. The proof is in the archive paper.
I will look for it there. Thank you. That's my question.
Okay, John.
So I'm going to disappoint Jeff by not providing a full history of BGP-SEC, but I wanted to just draw attention to a comment I made in the chat, which is, just for everyone's information, it is not an accident that BGP-SEC doesn't do partial path signatures. That was, thoroughly considered and debated by the design team. And Doug Montgomery kindly posted in the chat a link to the, there's a RFC that published the all the different design considerations that went into BGPSec. So at the time, the design team concluded that, in considering the attack surface that they were trying to defend against, that partial signing would be not only not helpful, but possibly harmful in that it would create sort of an appearance of security where none existed. I'm not saying that this necessarily applies to FCBGP. It sounds like you've done a careful analysis of your protocol. I haven't, but I do think that the working group, before adopting any security work, needs to make sure that they sit down and really carefully think through the security implications of the different design choice. So yeah, and please do, if you haven't already, go have a look at the BGPSec design choices document that Doug referenced. Thank you.
Thank you, Joe. Yeah, absolutely.
Okay, next, Alex.
Alex Antazimov, Yango. So as far as I understand, you are trying to add more security to BGP, and by giving some new attributes, it will sign partially the IS path. Normally, when we're speaking about giving more security to the IS path attribute, we're speaking about fighting some malicious activity that tries to forge the IS path in some strange manner. My question is, what protects from a malicious activity that will just strip your attribute from the IS path?
You can simply strip that. Yeah, there's.
Why can't I strip it? I can.
Yeah, you can. Yes, you can strip the you can strip the new attribute part. Yeah.
And how does it help to secure the IS path?
I mean, there's no way if you strip that part. Yeah.
Okay, thank you.
Yeah.
Okay, next is Randy.
I'm sorry, I just want to make one language point, which is, could we please be careful with the term partial deployment, which would mean part of the internet doing it, as opposed to partial path signing, which is what this intends to do. So it's not incremental deployment, it's partial path signing. That's all. I just don't want to fork the terminology and create confusion down the line.
If I understand the question correctly, maybe it's a little bit abuse of the terms, but what we mean here, partial deployment, is actually similar to the word you said, incrementally deployable.
No, I understand you have chosen to overload the term. I'm asking you not to.
Okay.
Please, it is partial path signing is what you are doing. You are signing part of the path. I'm not saying it's good or bad, etc. I'm not passing judgment on it. I'm saying we already have use for the terms of incremental deployment and partial deployment. Please don't overload those terms.
All right. Thanks.
Okay, if there's no more comments, I think we can. Yeah, I think all they have already finished. Okay, thank you.
Thank you, guys.
The next one is BGPRS flexible algorithm. Yes, remote. Let me share the slides. Wait a moment.
Hello, everyone. Able to hear me, right? Yeah. Okay.
You want me to?
G, can you hear me?
We can
Yes,
hear you.
we can hear you.
Okay, yeah. Okay, hello everyone. I'm Arvind. I'll be presenting this draft on behalf of my co-authors Shraddha, Ketan, Peter, and Bruno. The draft covers BGPLS support for FlexAlgo extensions in IGP. Next slide, please. Yeah. To go over the problem statement, the FlexAlgo enables operators to set up IGP to perform not just based on the regular path metrics, but constraint-based topology computations. Each FlexAlgo can be defined by the type of calculation to be used, like say SPF or SSPF. The metric types to be used, like say IGP metric, TE metric, or delays, and the set of include or exclude constraints to be applied, like extended admin groups and affinities. So basically, the PCE or the controller which learns these IGP topologies from multiple domains, and it tries to compute end-to-end SR policies. The advertisements of IGP FlexAlgo definition via BGPLS enables the controller or the PCE to map the intent of these SR policies to the FlexAlgo. So BGPLS extensions for FlexAlgo advertisement is already defined in RFC 9351. Next slide, please. This draft actually proposes new extensions which are defined in FlexAlgo enhancements in IGP area. So it covers for both ISIS as well as OSPF. We have defined three different set of TLVs, each covering different drafts in IGP. So to start with the first draft, that is RFC 9502, which defines FlexAlgo in IP networks. It's for using FlexAlgo definitions, advertisements for the regular IP v4 and v6 forwarding. We have defined two TLVs under this particular draft. The first one is IP algorithm, which specifies the algorithm associated with this particular node, which will be part of the BGPLS node attribute TLV. And the second one is IP algorithm prefix reachability TLV, which will be under BGPLS IPv4 or IPv6 prefix attribute TLV. It specifies algorithm specific prefix reachability from a given node. Next slide, please. The second set of TLVs correspond to the draft FlexAlgo bandwidth constraints. This one specifically talks about bandwidth and metric constraints, as well as it also suggests automatic metric calculation for use in SPF calculation. So as part of this LSR draft, we have defined a set of BGPLS TLVs. The first one of it is generic metric TLV, which will come under BGPLS link attribute TLV. It basically captures all the generic metric based on the metric types, standard as well as the non-standard metric types. The second set of TLVs are actually sub-TLVs, which will fall under the FlexAlgo definition TLV, which in turn is part of the BGPLS node attribute TLV. The first set is for the first sub-TLV is for FAD exclude minimum bandwidth. It basically advertises the minimum bandwidth associated with this FAD, which can be used for the FAD path computation. The second one is FAD exclude max link delay. It once again advertises the maximum link delay associated with this FAD. There are two TLVs which are defined for calculating the metrics automatically. The first one corresponds to FAD reference bandwidth TLV. It advertises the information needed for the reference bandwidth. Usually the bandwidth is sorry, the metric is inverse of the bandwidth, right? But in this case, there is a reference bandwidth that is used to get the metric associated with this FAD. And the second one is bandwidth threshold, TLV, which advertises the thresholds, different thresholds in a step kind of way, and the associated metric associated with that particular threshold. Next slide, please. Yeah. The third draft is related to FlexAlgo reverse affinity in LSR group. This draft defines to exclude or include link that are in the reverse direction of the traffic flow for SPF calculation. Yeah. So we have defined 3 sub TLVs under FAD TLV once again, and FAD TLV is already part of node attribute TLV. So for the reverse affinity, we have defined exclude any rule, include any rule, as well as include all rule. Yeah. Next slide, please. Yeah. As next steps, we are requesting for working group review and any inputs and feedback. Since these are straightforward extensions from IGP to BGPLS, we are also requesting for the working group adoption. Thank you. Any questions?
Any comments? Okay, no?
Yeah, thank you.
Thank you.
Just to add a quick comment as we're changing slides, these types of proposals tend to move fairly quickly, so please send in the adoption request and we'll get early review.
Hello. Hello, everyone. Slides are still coming up, I see.
Jeff, I cannot find these slides for the Young model.
It might be on second day. If not, I can always grab an older copy and share it directly. But it was actually for IDR chairs. Actually, in the interest of time, Jishnu, you should have the ability to share your desktop.
Yep. Just let me know if you can see my screen.
Sure, starting. And we'll get this fixed online because this is part of what goes into the proceedings.
Is it visible?
Screen share is not happening. You may not have permissions granted to your web browser.
I hope now it's visible, right?
It still is not visible.
Okay.
Did you propose? Can you check the email list?
Now we can see your screen.
Good to go. Thank you. Right. Hello, everyone. Myself, Jishnu. I'm from Juniper Networks. And today I'm presenting my entire team who has been working along with me on formulating this Yang model for BGP for including the route validation or RPKI related steps. So I'll be briefing it up a bit on which that we are working on. Majorly, this draft will be covering 3 Yang models. Primarily, the origin validation Yang, which is again informing about the parameters that we are including for originase validation in BGP. Second Yang model will be talking about the BGP sec path, and the third one is of BGP ASPA Yang. So the point that I should be noting here is that these 3 models are getting splitted up from the mother draft that was presented earlier. That was purely on RPKI stuff. So we plan to split this up from the mother draft because like we are separating the RPKI, purely RPKI related parameters and RPKI table related stuffs from the BGP organized validation. So briefing it up a bit on what was there previously, since we have split it up from the mother draft. Previously, like we have already like talked about the introduction of origination validity, like the states per route for IPv4 and v6 AFIs. Along with that, like we have introduced the parameters that like we'll be talking about whether we want to allow like the invalid routes to be streamed or like the routes that are unknown validation state to be streamed. And also with that, whether we are while we are exporting, whether we want to send the origination validation parameters on the routes. The changes that we are bringing in via this particular draft is we are including the eligible prefix policy parameter in the Young model, which is going to let us know about the restrictions on the prefixes, whether we can like put it or not based on the origination validation. We are introducing the statistics that we'll be talking about majorly on the validation state: valid, invalid, unknown, or unverified routes. Like per RIP specific or like per neighbor statistics. We'll be taking a look as to how these statistics will be placed in the model. Thirdly, like we have a parameter route validity invalid reason. Basically, this is going to sum up on the reason why we have stated a particular route to be validation state invalid, to be included along with the other parameters of origination validation. So with this change, it will nearly look something like this. Per IPv4 v6 unicast AFIs, we are going to have the new parameter validity invalid reason, along with the origination validity state, which is going to mention why this route has been marked as invalid. Other than that, we have the eligible prefix policy placed under origination validation. The statistics container will be placed per ribbon pre-post, locked rib, and rib out pre and post. That statistics is going to point us down regarding like the number of routes that are valid, invalid, or unknown. Right. Other than that, we have the eligible prefix policy like appended to the route selection option, along with the statistics container is also present as mentioned earlier, per neighbor, per group, and IPv4 v6 unicast AFIs. Okay. Similarly, like this is the second Yang model that this draft is covering. That is like related to the BGP sec. Similarly, we had the previous occurrence of this draft of this Young model, which consisted of the BGP sec validity state, with which determines the validation state of the BGP routes. The enabled, whether it's enabled or the invalids are allowed or not, that parameter, and the export BGP sec validation enablement or disablement. So there is only a single change in this Young model. We just introduced the eligible prefix policy, and that is basically appended on the BGP sec validation container of the IPv4 v6 or the route selection options and the export BGP sec validation containers. And something similar to ASPA BGP Yang as well. We had this particular IKEA model defined previously. We are including only the eligible prefix policies in that, which will be fixing in the local, which in the ASPA validation or the route selection options and the neighbor per group section. So majorly like this particular draft is dealing with introducing the parameters by which we can track down the validation states of the routes and reason for invalid, and accordingly the statistical data for valid, invalid, and unverified or unknown routes in the network. So the future prospect that why we're thinking about this is that the current AI boom that we are having maybe like will be in a prospect of streaming a huge amount of like telemetry statistics over the network for like multiple AI applications that will be ingesting these particular data. Any like comments, any suggestions that would help this to be adapted in the working group is welcome. That's all that I had. Any queries?
Oh, I didn't use the hands tool. Sorry if I talk.
Go ahead, AC.
You join the queue.
Yeah, AC Linum Lavin. Hey, I just looked at it and I saw at least the third Yang model is pretty sparse in terms of the descriptions. And I noticed the first Yang model you have AS origin validation, but then you decided in the third one to use just ASPA. And it's kind of annoying. It's because you don't even define what ASPA is until down at the end. It looks like, I'd say just make the descriptions and expand things out. And if you use, for the first one, if you use AS-origin, why can't you use AS-path for the third one of those? Anyway.
Okay. The naming
convention.
Yeah. Sorry. Yeah. Sorry. Yeah, I get that. Like the naming conventions need to be worked upon, and I absolutely take those points and I note it down. I'll be updating it accordingly. And yeah, like I will be revising this accordingly as per the comments. Yeah, take it up.
Okay, I appear to be next in queue. So thanks for the presentation, Jishnu. And AC, you should be giving these guys some a little bit of applause because this is one of their first sets of presentations in IETF. And this draft does actually need a lot of work, and they absolutely appreciate the help on that. I'm trying to lend them some procedural help. Some commentary from a perspective of the BGP Yang model. One of the things that IETF should be paying attention to this for, IDR in particular here, and a little bit potentially out of NetMod and NetConf, as IETF starts working through its streaming telemetry type models, things like these sorts of annotations are going to become more important for Yang push type situations. So the state that's in here are pieces of information that would be useful for streaming telemetry for internet routing security.
Yeah.
Thank you, Jishnu.
Thanks, Jeff. Thanks, everyone. I'll stop the share. Any queries or that's all? Thanks, everyone.
Thank you. And we have the last presentation for today. It is from Shenglin. Okay, wait a moment. We need to load the slides.
Hello everyone, I'm Shenglin from Zhuangqi Library, and I will talk about the problem about route-origin registry. According to the CADR statistics, around 10,000 mouse events every day. BGP stream found 10 possible hijacking, and there are some legal mouse events. For example, multi-homing and cost aggregation. There are similar characteristics with illegal mouse events, such as misconfiguration, hijacking. The draft target is to set the problem in distinguish between legal mouse and prefix hijacking. The current route-origin registry contains the RA objects in RPKI and route or route 6 object in IR or IR or third organization. Sure, current root-origin registry can support the legal mouse events, but there are some limitations, such as unreliable data quality, limited coverage, and early adoption lag. As we all know, in the mail list, IR updates time data is long. There are so many IRs. Average time update time is over 6 years. There are so many bogans in the root origins. Sure, some may be intentional for special purpose. Despite the prefix coverage has increased, but the most coverage is still limited. Among the matched mouse prefix, it only can be one or subset of ORIS. It may be hijacking, root leak, or others. Is this why operators avoid ROV?
Yeah, excuse me, could you speak to the mic? Because for the remote,
okay. Sorry.
The voice is not stable. Yeah.
Okay.
Thank you. Yeah, try again.
Further analyze, IR combined API can increase the coverage of mouse events, but there are different validation results about the mouse events. The same network registered in different IR database. The mouse may be registered in multiple IR database. Different network may be choose the subjects of IRS. So there will be different validation results regarding the same announcements. The synchronization and management protocol doesn't matter this problem. So many organizations advise future IR database with API, but it's limited the API coverage. So requirement, there are some requirements such as multi-party governance, leverage multiple source data and cross verification to improve data quality and coverage, and then develop an allow list from the prefix users, serving as a supplementary current registry mechanism for prefix owners, and integrate with internomy routing anomaly detection and multi-party governance to build a block list, mitigating abnormal mouse events. So today I talk about how to distinguish legitimate mouse events from malicious attacks. There are similar characteristics between them, but there are some limited, such as insufficiency of resolution certification, and in consistency between different root-origin registries, and security risks from partial adoption. yes, a wearable, complete, high coverage, route-only registry system, such as multiple governance, cross-validation, build the allow list to prefix the legitimate mouse, and build the block list to filter malicious attacks. That's all. Thank you.
Thank you. Any comments on this one?
Go ahead, John.
Thanks for your presentation. I guess my comment is, so far, this does not feel to me like a subject for this IDR working group. It seems more like something that would be appropriate for either Grow or Cider Ops. Interested in hearing what the chairs have to say about that, or any of the working group members.
Oh, thank you, thank you. I will. I want to welcome some conference from IDR group. Thank you, thank you.
So this is Jeff. I will repeat most of John's comments. We did discuss this on the mailing list. This work is probably best for Cider Ops and Grow. The feedback that was probably most important from the mailing list is that some of these multi-origin OAS issues are already covered by things like RPKI ROAS. That said, you seem to have potentially deeper work in mind, and I'm sure those working groups will be, thrilled to have, some additional discussion on the topic.
Thank you for your comment.
Yeah. Okay, I think that's all for the presentation on today's session. And Jeff, do you have anything to say for the
Closing comments for me? No, the last thing I'll say is that IDR has another presentation coming up on Friday's last session. So we'll hopefully see many of you there. Sue, did you have any closing comments? Sue types on the chat that she has nothing to add.
Okay. So thank you for attending today's session. I'll see you on Friday.